Next one, number 13. All right, determine which, if any, of the statements are equivalent. So let me write each one. The sun is shining. I'll go S. And Daniel mows, I'll go M. So if the sun is shining, then Daniel mows. That's my first one. If Daniel does not mow, so no mow, then no shining. The sun is not shining. Not shining or mow. Which of these are equivalent? All right. Well, they actually all are equivalent. And these are 3 rules that we should know. But supposing this is on the final and I don't remember, then I'm going to make a truth table, right? Or even if I just don't know my rules and I want to be sure. So there are 2 variables. I set up 4 rows. This is going to be true, false, true, false. So this is going to be false, true, false, true. This will be false, false, true, true. This will be false, false, true, true. And you can use P and Q if you want. I'm sorry if I confused you by using different letters. You'll have to forgive me. Alright. A conditional is only false if true leads to false, and that's right here. So the other ones are true. So this is what I'm looking to get. A conditional is only false if true leads to false, and that happens right here. All the other ones are true, so those match. And a disjunction is only false when both are false, so that's right here. And both of these match. Or both of these and both of those, and all of them match. So A is equivalent to B is equivalent to C. Let's look at the next one. 14. Statement A is Trig eats her dinner, then she is feeling better. Trig. So it looks like there's only 2 simple statements here. Let me get rid of this stuff down here. Alright, 2 simple statements. And I'll just call Trig eats her dinner. I'll do P, and I'll call this one Q. So the first statement is, it is not true if P then Q. The second statement, B, is it is not true Trig doesn't eat her dinner or she is feeling better. And then the last one is, if Trig is feeling better, that's Q, then she eats her dinner. Okay. Are any of these equivalent? Well, the first 2 are and the last one isn't. And I can just tell from inspection, but that's because I know my rules. Because I know, I can say A is equivalent to B, and then my reason would be because this is equivalent to what? What's inside. So I'm done. Okay, but for the last one, I know it's not, because I know not P there's no way to do this. Well, I know this one is equivalent to not Q or P, right? And I know this is equivalent to what I just said, not P or Q. Whoops, I forgot my P there. And so this thing above is P and not Q. So look what I have here, and look what I have here. I can switch the order, it doesn't matter. So this is equivalent to, up top, P or not Q. Is P or not Q equivalent to P and not Q? Heck no, right? And it's not equivalent to or. So that's one way I could do it. The alternative, So A and B are equivalent, but C is not. But the alternative to that is you can make a truth table for all of them. You can say true, true, false, false, true, false, true, false, 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 true, 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 false, true, false, and get that back in there. This is a P. This would be true, false, true, false, true, true, false, false. And then I'd just go through and I'd figure it out. And when you do, you'll get this. You'll get this as your answer. Whoops. Okay. Over here, you'll get and is only false when both are. So you'll get a false here. And then you get these are true. And so over here again, you'll get false, true, false, false. So this matches this. And then over here, you get a conditional is only false when true goes to false. So that's right there. And the rest are true. And you can see that true, true, false, true does not match false, true, false, false. So you can go like this with a big no, and those with just like that. Alright, let me do a time check. Wow, that's way too long. I'll just keep going and I'll split the video at some convenient point. So, let me minimize that. I translate the following argument into symbolic form to determine whether the argument is valid or invalid by comparing the argument to a recognized form or using a truth table. Alright, if Marion works out, then she eats a healthy diet. If Marion eats a healthy diet, then her cholesterol level goes down. And if Marion works out, then her cholesterol level goes down. That's R. So I have three statements here. And when I write the premises, it's if P then Q, and then if Q then R, and then therefore the conclusion is P to R. And I think that this is the law of syllogism. When you look in the book, page 155, pretty sure. Law of syllogism, yes it is. So, I can write law of syllogism if I knew that. If, however, I didn't, then I would have to make a truth table. And this truth table would have 8 lines. And what I would want to show is that the conjunction of the premises implies the conclusion. So let me do this. First premise was P if P then Q, and second premise if Q then R. It's kind of like the transitive property almost. Then if P then R. We actually did this one in class, but I'll do it again. You have 3 variables, so you're going to have 8 lines. I'll try to keep it neat. Oh, I already messed up. I'm just laying the groundwork, right? Under all my Q's, I put true, true, false, false. Under my R, I'm going to put true, true, false, false. Or sorry, under my R, I'm going to put true, false, true, false, true, false. And you saw what I did with P. True, 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 false, false, false. So I'm just setting this all up, and it's a little bit tedious. But if we don't know the laws and the name of the laws, this is what we have to do. Oh, be quiet, Mr. Wani Pants. Shh. It's my dog. He's being whiny. Alright. A conditional is only false when true leads to false. So that happens here on this one. Happens here on this one and here. Happens there and there on that one. So the rest I can just fill in with trues. See, when I do these, I always look for what the rule tells me. You know, the summary statement that I gave you guys. A conjunction is only true when both are true. A disjunction is only false when both are false. A conditional is only false when true goes to false. And a biconditional is only true when both sides agree. So I'm looking for those exceptional cases. And then I fill those in first, and then I fill in the rest after. So, and a conjunction is only true when both are true. So I'm going to look for true trues. And that's right there and right there. Anywhere else? Right there. Right there. And everything, whoa, is only true when both are true. What am I writing? I'm writing false. That's not good. A conjunction is only true when both are true. So let's try that again. It's true there. It's true there. It's true there and there. And everywhere else it is false. 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 Now I'm going to do this red with this orange over here. And what rule am I using? I'm doing this operation. That is a conditional. And a conditional is only false when true goes to false. So, ignoring the rest, I'm just looking for true going to false. So, on this side, here's a true, but it goes to a true. Here's another true, but it goes to a true. Here's a true, it goes to a true, and a true goes to a true. So there are no true going to false. So my answer is this whole thing is true. So it is a, what do we call that? It's implication because it's a tautology, right? When a conditional is a tautology, we call that an implication. So we can say that the premises imply the conclusion. So this is an example of a valid argument. Specifically, it is the law of syllogism.